on mild steel plate 10 mm thick in flat position using SMAW, shielded metal arc welding process.
Objective. At the end of this topic, you will be able to prepare MS plate of 150 mm length, 100 mm width and 10 mm thickness. Select the electrode and set the current. Deposit uniform straight bead in flat position. Inspect the job for any surface defects. Let us now look at the required tools and equipment for SMAW process. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine and their setup accessories, C-clamp. Let us now see the pre-welding preparations for straight line beads on MS plate 10 mm thick in flat position using SMAW process. Wear protective clothing. Prepare a mild steel plate piece of 150 mm length, 100 mm width, 10 mm thickness using hacksaw. File the cut plate. Ensure the job piece is free from oil, grease, paint, dirt, etc. Clean the plate surface with a stainless steel wire brush. Remove the burr by filing. Mark parallel lines on the job surface as per the drawing. Make a punch mark on the line to deposit straight bead. Set the job on the welding table in flat position with the punched surface facing up. Ensure the plate is contacting well with the welding table and the earth clamp is not loosely connected with the work table. Connect the electrode cable with the welding machine. Select 4 mm dia medium coated MS electrode. Set the welding current between 150 to 160 amps. Let us now see how to perform the welding process of straight line beads on MS plate 10 mm thick in flat position using SMAW process. Strike an arc on a scrap piece and adjust the current if necessary. Place the electrode with the weld line at an angle of 75 degree to 80 degree. Start moving forward at a moderate pace and in a medium length arc. Deposit the straight beads on the workpiece on the punched lines from one end to the other. When the arc is turned off or when the electrodes are changed, restart the weld. Whenever the arc is broken, a crater is formed at the breaking point, and this crater has to be filled first while restarting the arc. Clean the crater and generate an arc at about 20 mm ahead of the crater. And return to the crater at a faster rate. Build the deposit so that it fills the crater, then move the electrode ahead. Finally, stop the welding and stop the forward movement of the electrode. Use goggles and tongs during deslagging. Using a chipping hammer, deslag the weld bead. Clean weld bead with a steel wire brush. Inspect the weld bead for any surface defects. There are some important points to be followed for straight line beads on MS plate 10 mm thick in flat position using SMAW process. The bottom surface of the job should be perfectly clean to get good electrical contact between the job and the welding table. Always follow the current range according to the diameter of the electrode as given in the electrode packet by the electrode manufacturer. Check for proper melting of the job and electrode on a scrap metal piece. Check the deposited beads and note any variation in the width and height using a weld gauge. Let us inspect straight beads for uniform width and height of the bead, straightness of beads, uniform ripples, undercut, porosity, slag inclusion, unfilled crater,
Recap. Let us do a quick recap of what you have learned from this topic. Prepare the mild steel plate piece of 150 mm length, 100 mm width, 10 mm thickness. Set the current and polarity, then choose the electrode. Deposit uniform straight bead in flat position. Inspect the job for any surface defects. Thank you, students. I hope all of you understood this concept better. We'll see you in the next session. Hello, students. Welcome all for today's session. In this topic, you are going to learn about how to perform weaved beads on an MS plate 10 mm thick in a flat position using SMAW process.
At the end of this topic, you will be able to prepare a MS plate of 150 mm length, 100 mm width and 10 mm thickness. Select the electrode and set the current. Deposit uniform weaved bead in flat position. Inspect the job for any surface defects. Let us now look at the required tools and equipment for SMAW process. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine and their setup accessories, C-clamp. Let us see the pre-welding preparations of a weaved bead on MS plate 10 mm thick in flat position using SMAW process. Wear protective clothing. Prepare mild steel plate of 150 mm length, 100 mm width and 10 mm thickness. Make sure the job part is clean from oil, grease, paint, dirt, etc. Clean the job surface with a steel wire brush and file the edges. Mark parallel lines on the job surface. Make a punch mark on the line to deposit straight bead. Set the workpiece on the welding table in flat position. Select 4 mm dia medium coated MS electrode, BIS code ER4211. Set the welding current between 150 to 160 amps. Let us see how to perform the welding process of a weaved bead on MS plate 10 mm thick in flat position using SMAW process. Strike an arc on a scrap piece and adjust the current if necessary. Maintain the electrode's position with the weld line at an angle of 75 degree to 80 degree. Start the travel at the normal rate with medium arc length. By carefully positioning the electrode, beads can be deposited between the punched lines. Use a weaving technique that is moving the electrode side to side. When the arc is turned off or an electrode is changed, restart the weld. If a crater arises, move the arc slowly across the crater, reducing the arc length and filling the crater. Move back along the weld about 15 to 20 mm. Hold for 2 to 3 seconds to fill the crater. When welding is complete, fill the crater. At the end of the weld, stop the forward movement of the electrode. Use chipping goggles and tongs during deslagging. Using a chipping hammer, deslag the weld bead. Clean weld bead with a steel wire brush. Inspect the weld bead for any surface defects. There are some important points to be followed for a weaved bead on MS plate 10 mm thick in flat position using SMAW process. To ensure a good restart, proper fusion and fill up at the crater, proceed as follows. Remove slag 10 to 15 mm from the end of the crater. Change the angle of the electrode. Move back along the weld about 15 to 20 mm. Hold for 2 to 3 seconds to fill the crater. Let us inspect the weaved beads for uniform width and height. Straightness of beads. Uniform ripples. Overlap on sides of the weld. External weld defects like undercut, porosity, slag inclusion, unfilled crater.
Let us do a quick recap of what we have learned in this topic. Prepare MS plate piece 150 mm length, 100 mm width, 10 mm thickness. Select the electrode and set the current and polarity. Deposit uniform straight bead in flat position. Inspect the job for any surface defects. Thank you, students. I hope you have understood the topic. We'll meet you in the next class.
Welcome to oxyacetylene gas cutting. In this module, you will learn to set the oxyacetylene cutting plant and perform different operations like straight cut, bevel cut and circular cut on a 10 mm mild steel plate.
Let us look at how to set up an oxyacetylene plant. The purpose of oxyacetylene gas cutting is to cut mild steel. A mix of oxygen and acetylene burns as an intense flame at 3100 degrees to to 3300 degrees Celsius. And when the flame meets steel, it melts the surface, forming a molten pool, which allows cutting to take place. Oxyacetylene equipment is very safe if it is properly handled. By following all safety measures, but it may become a great destructive power if handled carelessly. It is important that the operator be familiar with all the safety rules before handling gas cylinders. While handling the cylinders, remember the following.
Wear personal protective equipment like welding gloves, helmet, leather apron, leather boots, welding goggles, and other personal protective equipment to help prevent weld burns and injury.
Keep the gas cylinders away from exposure to high temperature. Remember, the pressure in the gas cylinders increase with temperature. Always keep the cylinders upright in the cylinder stand or on the floor. Do not roll the cylinders horizontally on the ground. While moving the gas cylinders, they should be kept slightly inclined, and the protector cap has to be used to avoid damage to the cylinder valves. Remove the cylinder caps. Crack the gas cylinder valves by quickly opening and closing the cylinder key. This is to prevent dust particles from entering the regulators and to avoid damage to the regulators. Never apply undue force to open or close a cylinder valve and avoid the use of a hammer or wrench. Smoking or naked lights should be strictly prohibited near gas cylinders, and never strike an arc or direct gas flame on a gas cylinder. Always stand opposite to the valve outlet while opening the cylinder. Always use the correct size spanner to prevent damage to the threads. And never apply lubricants in the threaded assemblies of gas welding equipment. It can cause fire. Always use the correct size key to avoid damage to the square rod used to operate the valve. The key must be always left on the valve socket itself, so that the gas flow can be stopped immediately in case of flashback or backfire. The spark lighter is used for igniting the torch. While welding, form the habit of always employing a spark lighter to light a torch. Never use matches. The use of matches for this purpose is very dangerous because the puff of the flame produced by the ignition of acetylene flowing from the tip will burn your hand. Always secure the joints with hose clips to ensure good grip and to avoid gas leakage. Apply soap water solution for checking acetylene connections and fresh water for oxygen connections. Never use soap water for oxygen connection. It may lead to fire hazards, and never ever use matches or flame light during leakage tests. Leakage tests should be carried out for cutting torches.
Recap.
Set up an oxyacetylene plant. It is important that the operator be familiar with all the safety rules. When the flame meets steel, it melts the surface, forming a molten pool, which allows cutting to take place. The key must be always left on the valve socket itself. Leakage tests should be carried out for cutting torches.
Now, let us see about oxyacetylene plant lighting.
Open the gas cylinders and set the gas pressures on the regulators. Set oxygen pressure to 1.6 kg per square centimeter and acetylene pressure to 0.15 kg per square centimeter. Oxygen pressure regulator is used to reduce the oxygen cylinder's gas pressure to the required working pressure and to control the flow of oxygen at a constant rate to the blowpipe. The threaded connections are right-hand threaded. Acetylene regulator is used to reduce the cylinder gas pressure to the required working pressure and to control the flow of acetylene gas at a constant rate to the blowpipe. The threaded connections are left-handed. For quickly identifying the acetylene regulator, a groove is cut at the corners of the butt. Then, open the acetylene control valve to 1/4 turn on the blowpipe and ignite with a spark lighter. Acetylene burns using oxygen in the atmospheric air. Never use any other source of fire other than the spark lighter. Now, observe the flame and add oxygen by opening the oxygen control valve of the blowpipe. Now, a bright white cone starts appearing at the tip of the nozzle. There are 3 different types of flames based on the ratio of oxygen with acetylene. Neutral flame, oxidizing flame, carburizing flame. Neutral flame. Oxygen and acetylene are mixed in equal proportion in the blowpipe and complete combustion takes place in this flame. This flame does not have a bad effect on the base metal or the weld, which means the metal is not oxidized and no carbon is available for reacting with the metal. To adjust the neutral flame, add sufficient oxygen to make the white cone clear and round. Oxidizing flame. An excess oxygen added to the neutral flame creates an oxidizing type of flame. The oxidizing flame is hotter than the other 2 flames. To adjust the oxidizing flame from neutral flame, decrease acetylene flow. Carburizing flame receives an excess of acetylene over oxygen from the blowpipe. To adjust the carburizing flame, adjust the flame to neutral and then add acetylene. After continuous use of the blowpipe during cutting, the nozzle may get blocked by metal particles or spatters. To remove this blockage, nozzle cleaner is used. A special tip cleaner is supplied with the torch container. For each tip, there is a kind of drill and a smooth file. Before cleaning the tip, select the correct drill and move it, without turning up and down through the tip. At the close of work, shut off the plant by first closing the acetylene cylinder valve, then close the oxygen cylinder valve. Now, open the blowpipe acetylene valve and oxygen valve and release all the gas pressure. Both the pressure gauges on the regulators should read 0. Then, release the acetylene and oxygen regulator pressure adjusting screw. Now, close the blowpipe acetylene valve and oxygen valve.
Recap.
Set the gas pressures on the regulators. For quickly identifying the acetylene regulator, a groove is cut at the corners of the butt. Ignite with a spark lighter. 3 different types of flames based on the ratio of oxygen with acetylene. Select the correct drill and move it, without turning up and down through the tip. Shut off the plant by first closing the acetylene cylinder valve, then close the oxygen cylinder valve.
We have learnt about setting an oxyacetylene plant and safety measures earlier. Now, let us look at how to perform straight cut, bevel cut of a 10 mm mild steel manually, keeping it flat.
At the end of this exercise, you will be able to set the workpieces for a cutting, adjust the gas cutting flame, and gasket manually, observe safety while cutting with gas, and how to inspect the gas cut surfaces.
Now, let us see the tools required for cutting.
Steel rule, scriber, prick punch, ball peen hammer, hacksaw frame with blade, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, circle gas cut guide, material marker, radius bar, C-clamp, gas cutting plant, personal protective equipment. There are different varieties of nozzles available for different metal cutting. Let us see the preparation for the practical. Cut a piece of 10 mm mild steel flat. Remove burrs, if any, by fixing it on a vise. check for the squareness of the MS plate. Punch along the straight line for gas cutting using a prick punch tool. Now let us see the procedure of straight cutting of a 10 mm thick MS flat manually. Set the gas pressure to 1.6 kg per square centimeter for oxygen and 0.15 kg per square centimeter for acetylene. Fit the correct cutting nozzle of 1.2 mm dia, orifice cutting nozzle. Set the gas welding plant with a cutting blowpipe and cutting oxygen regulator. In a 10 mm thick MS flat, mark and punch the straight lines 25 mm apart. And set the neutral flame. Now, hold the blowpipe at an angle of 90 degrees between the line of cut and the cutting nozzle axis and between the nozzle and the surface of the plate. Preheat the starting point of the punched line to red hot condition. When preheating the starting point of the cut, hold the torch tip close to the surface of the plate. When the metal is hot enough, slowly depress the cutting lever and raise the torch to avoid blowing slag back onto the tip. When the plate has been pierced completely, lower the torch. Begin moving the torch along the line to cut. A short backward movement before the cut is carried out to clear the slag from the curve. Release the extra oxygen. Observe the cutting action and start traveling along the punched line at a uniform speed. Also, move the cutting blowpipe straight and avoid side-to-side movements. On completion of the cut, release the cutting oxygen lever and shut off the flame. Now, let us see bevel cutting of a 10 mm MS flat manually. Set the job on a rigid table and ensure the underside of the cut line is clear. Then adjust the cutting flame. Set the gas pressure to 1.6 kg per square centimeter for oxygen and 0.15 kg per square centimeter for acetylene. Fit the correct cutting nozzle of 1.2 mm dia, orifice cutting nozzle. Then set the cutting nozzle in the blowpipe and adjust the neutral flame for preheating and hold the cutting blowpipe nozzle at a 45-degree bevel angle. With an angle plate also, the bevel cut can be cut. Place the blowpipe along the angle plate and start the movement. Now, preheat the starting point of the punched line of MS plate to a cherry red color. Distance between the workpiece and the nozzle tip should be maintained as straight cut to avoid backfire. Release extra oxygen. Observe the cutting action and start traveling along the punched line with a uniform speed and steady hand. The cutting speed should be less than that of a straight cut. Also, fix suitable straight bars to the cutting job to ensure a straight cut and angle maintenance. Now, let us see the inspection of the cut. A good quality cut is indicated by a straight top edge and extremely smooth cut surface. Poor quality gouging is a common defect in gas cutting. This is caused by excess speed or too mild a heating flame.
Recap.
Set the workpieces for a cutting. Adjust the gas cutting flame. Gasket manually. Observe safety while cutting with gas. Clean the gas cut surfaces.
Now, we'll look about cutting a 10 mm mild steel plate in circular manually.
Now, we will look at how to cut a 10 mm MS plate in a circular manually. At the end of this exercise, you shall be able to set the workpieces for a circle cutting by oxyacetylene gas cutting process, and then adjust the gas cutting flame. Gas cut along a circle cutting by hand. Observe safety precautions while cutting with gas. Clean the gas cut surfaces.
Wear personal protective equipment like welding gloves, helmet, leather apron, leather boots, welding goggles, and other personal protective equipment to help prevent weld burns and injury.
Now, let us see the preparation needed for the exercise. Set the gas cutting torch and connect the oxygen and acetylene cylinders, regulators to the hoses and fix a suitable cutting nozzle and clean the surface of the metal plate to be cut. Fix the 1.2 mm nozzle to cut and set the correct gas pressure of 0.15 kg per centimeter square for acetylene and 1.4 to 2 kg per centimeter square for oxygen. Hold the blowpipe to a height such that the inner cone of the preheating flame is away from the surface of the metal to be cut. Now, we will look at how to cut a 10 mm MS plate in a circular manually. Now, spark light and set the neutral flame and allow for sufficient preheating. And press the lever jet of oxygen release. When the plate becomes red hot, open the stream of cutting oxygen and cut the circle. For cutting a circle, attach a cutting torch nozzle to the pivot block and follow the same method used to cut straight line and bevel. It is important to pierce a small hole inside the circumference of the circle to be cut and then move the torch to the nearest point on the circumference. Then use the pivot block to move the flame along the circumference of the circle. After the cut is over, remove the slag from all the gas cut surfaces. Ensure that the molten slag and solidified hot slag that are chipped fall through below the table. Inspect the cut for gas cutting defects. Let us see some common cause of oxyacetylene cutting deficiencies. Cutting speed is too low. Cutting speed is too high. Nozzle is too far from the surface. Nozzle is too close to the surface. Oxygen pressure is too high. Oxygen pressure is too low. Excessive preheat flame. Incorrect nozzle.
Recap.
Set the workpieces for a circle cutting. Adjust the gas cutting flame. Gas cut along a circle cutting by hand. Observe safety precautions. Clean the gas cut surfaces.
Lap joints are two pieces of metal that overlap and are welded at the edges. Now, let us look at how to perform a fillet lap weld on a mild steel plate in a flat position by SMAW process.
At the end of this exercise, you shall be able to prepare plate pieces by gas cutting and by grinding to size. Set plates as a lap joint and tack weld at both ends. Place the lap joint in a flat position for welding. Deposit root run of proper size and ensure penetration. Deposit the final covering run in the lap joint of proper leg size. Inspect the lap fillet weld for surface defects.
Now, let us see the tools required for fillet welding.
Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, angle iron, electrode cable and earth cable, electrode holder, electrode hand shield, marking material, personal protective equipments, SMAW welding plant machine and their setup accessories, C-clamp.
Now let us see the procedure for the fillet lap weld by SMAW process. Cut the plate pieces by gas cutting and grind the gasket edges to square. Remove the grinding burrs and clean the surfaces. Set the pieces in the form of a lap joint as shown. Tack weld on both ends and ensure the two lapping surfaces are perfectly cleaned and they contact each other properly. Use a 2.5 mm MS electrode with 120 amp current for tacking. Set the lap joint in a flat position and remove the slag with a chipping hammer and clean the weld with a steel wire brush. Now, let us look at how to perform a fillet lap weld on a MS plate in a flat position by SMAW process. Deposit root run by using a 2.5 mm dia medium coated MS electrode with 100 to 110 amps current. Deslag and clean the root slag thoroughly. Ensure an electrode angle of 45 degrees with the fillet corner and 80 degrees with the welding line. Maintain a short arc to get uniform fusion and root penetration and avoid side-to-side movement of the electrode. Deposit the final covering run with a weave motion using 4 mm dia medium coated MS electrode with 150 to 160 amps welding current. Give side-to-side movement to the electrode not more than 2.5 times its dia. Prevent the upper edge of the plate from melting off by not allowing the arc to concentrate more on the upper edge. Clean the weld with a steel wire brush. Inspect the lap fillet weld for surface defects and size.
Recap.
Prepare plate pieces by gas cutting and by grinding to size. Set plates as a lap joint. Tack weld at both ends. Deposit root run of proper size and ensure penetration. Deposit the final covering run in the lap joint of proper leg size. Inspect the lap fillet weld for surface defects.
अरे गीता, तुम मेरे घर आई ये तो बहुत अच्छी बात है। वास्तव में मुझे इंटरनेट के बारे में कई महत्वपूर्ण बातों को समझने में तुम्हारी मदद की जरूरत है।
जरूर चाचा, मैं यहाँ आपकी मदद और मार्गदर्शन के लिए आई हूँ।